Multiplying out these fractional functions, I actually find them a lot easier than adding or subtracting these rational functions. The reason being is because I guess it's the same as when you multiply fractions. It's a lot easier than adding or subtracting fractions because you don't have to deal with this crazy same denominator nonsense. What I would do, however, is I would factor every single thing as much as I can. For example, this 5x plus 15, I can pull out a 5. That just becomes x plus 15. No, oops, I'm sorry, it's x plus 3, right? Yeah. The 2x I can't really do anything with, so I'm just going to leave that there. Times, I can pull out a 2 out of the 8x minus 2, so I'll have a 2 out here, and I'll have a 4x minus 1. And then over here, the denominator over here, I can actually break that down. I actually see that as a difference of two squares. See the x squared, and the 9 is actually the square because it's 3 times 3. So if you make this x, and then you have a plus and a minus 3 and a 3. If you don't believe me, FOIL out that bottom one and you'll actually see that I'm telling you the truth. Canceling out as much as I can cancel this 2 with that 2. And I can cancel out this x plus 3 with that x plus 3. That's my favorite part. So what I'm left with is 5 times 4x minus 1. That's what's in the numerator. Divided by x times x minus 3. That's what's in the denominator. So this is your answer. If you want to write it in standard form, and you remember what standard form for quadratic is ax squared plus bx plus c. Basically, you multiply it all out. I would have to write that as 20x minus 5 divided by x squared minus 3x. And actually, to be honest with you, this is technically the correct answer, but when I ask you what is the correct answer in the quiz, I do want you to take that extra step and turn it into standard form, and then tell me what the a, b, and c are, the coefficients of this. In this case, the a would be 0. I'm talking about just the numerator, because there is no x squared term. The b would be 20, and the c would be negative 5. And that's what I would use to describe the quadratic, quote unquote, of the top, even though that is technically not a quadratic. All right, let's do the divide one right here. X squared minus 1, as I stated previously, that is actually a difference of squares. So that would be x plus 1 times x minus 1. Keep in mind, there is no such thing as a sum of squares. The only formula that I know of is for the difference of squares. 3x. Now I'm going to do a step over here, and hopefully you'll be able to hang. I'm going to make this a multiply x minus 9 divided by x plus 1. And what I'm doing here is I basically, instead of dividing, I multiplied by the reciprocal. I flipped it over and I multiplied it. Let's see, what can I cancel out? This is my favorite part. This x plus 1 gets killed with that x plus 1. And my answer that I'm left with in the end is x minus 1 times x minus 9 divided by 3x. I can put that in standard form by FOILing out the numerator, and so I have x squared minus 9x minus x plus 9 over 3x. What is that equal to? That would be x squared minus 10x plus 9 over 3x. This is my answer. My excluded value says x cannot be equal to 0. All right.